We are standing near Oak Ridge, Tennessee, and we're on the University of Tennessee's Forest Resources and Research Education Center, basically their version of an experimental forest. And we are partnering with the University of Tennessee Institute of Agriculture and the Tree Improvement Program to put in a study out here. And where we are geographically, I think it's important to understand where you are on the landscape and the history of that landscape in a broad sense. We're in the Ridge and Valley province, the southern end of that. The Ridge and Valley goes all the way from New York all the way down into Alabama. And it has a very long history of disturbance. And the disturbance history in the Ridge and Valley is actually quite complex. So historically, Native Americans were heavily populated in this area, and they used prescribed fire for all kinds of reasons. They also selectively harvested trees for their use to making canoes, for firewood, etc. They also did some agriculture, and then European settlement starting around 1800 came in, and of course the Native Americans by that time were largely extirpated by disease. And when the Europeans came in, they actually did do a lot of burning at the beginning of the European settlement period, and then they also did a lot of grazing and pasturing. So where you are today was heavily grazed and pastured for probably decades. And then late European settlement, we had a period of forest recovery for a time, but then there was also a very large cut that happened late 19th century, early 20th century, and that happened throughout the eastern United States. So things were heavily logged, heavily cut over, again, pastured, grazing, etc. going on, and uncontrolled wildfire. So this was a time of intense disturbance events, and that created the forest you see today. So pretty much in a lot of the areas of the eastern United States, and particularly the southeastern United States, there's probably most of the forests are between 80 to 100 years old, and they're mostly even-aged forests. And this forest that you're seeing here is absolutely no exception to that. So this forest is about 80 to 100 years old. It's dominated by species like this white oak over here, which is definitely a species of interest for a number of reasons. White oak provides very important wildlife habitat and also food source. It's a hard mass species. Historically, we had another species here that you will not see called the American chestnut, Castanea dentata, which was extirpated by an exotic pest from Asia, the chestnut blight. But what took over after the chestnut kind of fell out around the 1940s was oak, in particular white oak. And we also have some northern red oak, which is another species of interest, also a hard mass species. And silviculturally speaking, the northern red oak in these neck of the woods is probably the species we actually know the most about, which actually is not a lot. We still have a lot to learn in these diverse ecosystems. Also on this site is red maple, which there's a lot of red maple. It tends to be smaller in diameter, not because necessarily it's younger, but maybe because it came in and didn't grow as competitively as the oaks, which is something we're trying to figure out why that occurred. Because now our biggest issue is trying to get oak regenerated on these sites. And even though what you see around here is dominated by oak, about 75% of the species in the overstory are oak. When we come in and do a disturbance, or a disturbance happens naturally, we tend to not get oak back. We get things like yellow poplar, which you will not see much here because we're in a very shaded environment, but if you disturb this, the poplar seeds in and takes over a site. But we also get red maple coming back because it's already here, it's already established, it's in the mid-story, and it comes in and can take over as well. So this particular stand, the basal area is about 132 square feet per acre, about 125 stems per acre, and these are for stems greater than 6 inches in diameter, or the saw timber size stems. The quadratic mean diameter is around 14 inches. So those were our starting conditions. prior to implementing the study. And one thing that we are considering throughout the study is not only the disturbance history I told you about, but also the specific soil conditions. These forests here are what we call cherty dolomite soils. So the soils are made up of, are weathered, highly weathered from old parent material of cherty dolomite. Because they're highly weathered from old parent material, they pretty much have a low nutrient content. And the soil moisture holding capacity is fairly low. They're pretty well drained to extremely well drained. They do not hold water. The soils are ultisols generally, and so we're always considering that when we're looking at management options and doing prescriptions. All right, I just wanted to talk a little bit about fire and fire history. A lot of people talk about oak regeneration. Here's a little oak seedling, red oak seedling here. And they talk about how fire benefits oak regeneration and how it has to be part of the process to regenerate oak. And I think it's a little more complex than that, and a little more, we need to get a little more in depth on that. So fire has been part of these ecosystems for tens of thousands of years, starting with Native Americans. It's largely anthropogenic in these systems, which is going to be a little different maybe than out west, where you have fire starting from thunderstorms and things like that. But also out west, in a lot of areas, fires are also an anthropogenic process. Just in the east, it's almost always an anthropogenic process. And so fire has been here for tens of thousands of years. Native Americans have burned for a variety of reasons, from reducing insect pests to helping clear the forest floor to find hard mass better, to benefiting game species, etc. Killing individual trees. They would set fires around individual trees to kill them, so then they could harvest them better. And then Europeans came in. Native Americans were extirpated with disease and war, and then the Europeans kind of followed a little bit in the Native Americans at the beginning using fire, but then we had fire suppression, and that has lasted for over 100 years, and that has really changed the forest you see around here. And so, we had fire suppression coupled with indiscriminate logging that created these forests you see today. And the oaks largely benefited from that very heavy cut that occurred in the late 19th, early 20th century, along with grazing, along with the loss of the American chestnut. And then you had fire suppression. And so now when we try to get these forests regenerated back to oak, we are having lots of problems. And what's happening is there is the lack of fire that's been occurring for decades, which has changed the forest dynamics, changed the forest floor, changed the species composition that we see, and basically led to messification of these forests. But fire alone cannot bring back oak. We have to do more. We know this. We have to introduce disturbances to the overstory in order to get the disturbance processes we need in order to get oak to regenerate. So yes, fire can be part of that, but it also has to be part of a series of other disturbances. And frankly, some of that we just don't totally understand. And that's one of the reasons we put in the study that you're looking at today, that in fact does not involve fire, but involves other disturbance events and processes in order to hopefully regenerate oak. So one of the first questions you have to ask yourself when you're looking at managing a stand is, do you want to manage what's there, or are you ready to regenerate that stand? And so when we came out here and we talked to the manager of this area, and we talked about his objectives and what that would be for this experimental forest, we could have decided easily to go ahead and work with what was out here and manage this stand and do some intermediate treatments such as thinning to improve the trees that we have out here and improve the health, improve the timber quality, etc. Because these forests are about 80 years old. They're in the understory reinitiation phase of stand development. They've still got quite a longevity left in their life because they're dominated by white oak species that live a long time. So we could have decided to manage what was here, but we decided to go ahead and do some regeneration treatments, mainly because the objective was to maintain oak species over the long term and also provide timber revenue into this area. And so we decided to go ahead and regenerate the stand. One of the second questions you have to ask yourself is, well, what are the goals of the regeneration treatments that you're going to put in? And the goal was, number one, to maintain the oak component that we have out here. As I mentioned, this stand is about 70% oak, predominantly white oak species, including chestnut oak and white oak. And so that was like one of the number one objectives, was to maintain the oak component. The other objective was to provide timber revenue. And so we wanted to make sure we did both of those things. So one of the options that we decided to implement was an uneven aged treatment. And that is this treatment that I'm standing next to. And this treatment is called the expanding gap treatment, or some people refer to it as a Femelschlag. And basically it's an area controlled version of group selection. So you're basically taking 10 to 20% of the stand and regenerating it during the first entry. And then every 10 years or so, coming back into the stand and expanding around this existing gap that you see here. And in about 4 or 5 entries, you will regenerate the entire stand. And so you'll also have 4 or 5 age classes at that point. And another important management objective of this particular area was not just oak regeneration, but it was also aesthetics and the public perception of what was going on out here, and also providing heterogeneity into the landscape. So a lot of the forest around here are even aged. They're pretty homogeneous. There's not a lot of early successional habitat, and this was one way we could get a little bit of early successional habitat and provide a diversity of habitat for different wildlife species, birds, etc., deer that require them. And also for the public, in terms of visual quality objectives, this is something that they like. They see a small gap opening, it quickly fills in with the regenerating species, and they think, wow, that's visually appealing. And as opposed to something that's a more even-aged treatment, such as a shelter wood or a clear cut. In addition, it provides a little bit of a habitat mixture for bird species that like that little bit of heterogeneity in terms of structure. And so we're providing, hopefully, all of those benefits out here. The expanding gap treatment, as I mentioned, it's an uneven age treatment. Each gap that we put in was about ½ an acre in size. We made the gaps oblong in shape so that when we come back in and do our re-entry, the gap width of our expansion doesn't decrease over time. So each gap is roughly 200 feet across by about 100 feet across, so a little bit oblong in shape. And like I said, in about 50 to 100 years, we'll pretty much have regenerated the majority of this stand. Some of the concerns associated with expanding gaps might be that it's going to bring in less timber revenue than if you're doing an even age treatment such as a shelter wood harvest, which I'm going to talk about later. So that's definitely a concern. Also a concern is that you need a good road system to get the gaps put in, because they're spaced out throughout your stand. And so that's definitely something you want to consider. And so this may not work for every system that you're in. You may have to combine this with other larger treatments such as clear cuts or shelter woods to bring in that timber revenue, to get a logger out here to induce them to come out and make this commercially appealing to them, which is in fact what we did here. We had coupled this with some shelterwood treatments that I'll talk about later. And so in the expanding gap, one of the things we're really interested in, of course, is oak regeneration. And the prediction of this particular treatment was that we would get oak to respond within the gap, of course, along with everything else. Anytime you do a regeneration treatment and open up the canopy, you're going to get everything to respond, such as you see here: poplar, cherries, everything is coming up, including oak. Okay, but where we're really going to see the benefit we predicted would be the edges of the gaps, because on the edges where I'm standing, you've got just enough light coming in to produce a response from oak, but not so much light coming in that those shade intolerant species like poplar are going to start taking over. So that was where we predicted we would see the best oak response, is along the edges of these gaps, and particularly the north side of the gap, which is actually where I'm standing, because that's where you have the most amount of photosynthetically active radiation coming in. So that was our prediction going in. And we also wanted to look at the forest matrix, which is outside of the gap. And so we established plots out there to look at the natural regeneration that would come in just outside the gaps. And so that when we expand these gaps over time, if the regeneration at that point would be competitive. Oak Silviculture 101. One of the things that you always need to remember about oak silviculture is that the number one rule is that oaks have to be present in the stand prior to any disturbance event in order to be competitive, in order to be possible to recruit into the next stand. Not only do they have to be present, they have to be sufficiently large. And so one of the hopes of this expanding gap treatment was that around the edges of the gaps, and maybe just outside the gaps into the forest matrix, is that oak would start to develop and become large, advanced regeneration, so that when we come back in and do our re-entry, then those oaks would respond to that and become competitive and be able to be part of the next generation of the next stand coming up. So that was our goal, and we've got plots, going from the center of the gap all the way out in the 4 cardinal directions, outside of the gaps into the forest matrix, to be able to monitor that. One of the things you want to consider when you're doing a planting job is the site preparation. And that can look like a lot of different things depending on your local site conditions and the species that you want to regenerate. And it's also going to, really depend on costs. Site prep is going to cost money to implement. So you can look at, different types of mechanical site preparation to remove slash, to remove competitive species, to prevent them from coming up and being on the site. Burning is also an option for site prep, especially in eastern forests. That's a very usually a really cheap method of preparing your site for planting. It gets rid of a lot of the slash that's out there if you're planting in a timber harvest. It also does tend to knock back some of these competitive species, particularly like red maple and things like that. But you really have to think about it in terms of a cost benefit analysis, in terms of, how much is it going to cost for you to do this particular site prep versus the benefit that you're going to get. So if you're, for example, working in the deep south in shortleaf or loblolly pine stands, you're going to have a lot more money to work with, particularly if you're cutting a loblolly pine plantation out and restoring it back to shortleaf pine or longleaf pine. You're going to be pulling out a lot more money per acre on that site versus a stand like this, which is an upland hardwood stand. You're not going to have as much money to work with. And so for this particular stand, we didn't actually do a lot of site prep. We did the herbicide treatment I told you about, which is where we went in and basically treated all the undesirables under 6 inches in diameter prior to the harvest to prevent them from sprouting, to prevent them from being competitive with our oak seedlings that we planted, but also with the natural regeneration of oak. If I had my druthers, I would have really liked to have burned this site to make it a little more clear, to get rid of some slash, to lessen the competitive ability of some of these competing species. But because we are close to urban centers, because the boundaries of this particular experimental forest are really close to neighborhoods and also major highways, the smoke management was a concern, and so we couldn't use fire as a site preparation treatment. And I'm sure you guys are dealing with those same types of concerns in your forests. What we found with the expanding gap treatment was that the trees, the oaks that we planted along with the natural regeneration of oak, did respond within the gap centers, which is where we're standing now. So these oaks were able to grow up with the increase in light they were created by making the gap. However, everything else responded as well. As you can see, we're surrounded by poplars, a little bit of red maple, but mainly the gaps were occupied by that light-seeded species, tulip poplar, which came in and really started to grow from seed and very quickly took over and occupied the gap. And in the gap right now, we're pretty much approaching stem exclusion stage, as you can see. So at this point in the development of the gap, there's not going to be much else coming in to occupy this site. This site is now pretty much fully occupied, and we're in that density dependent mortality stage where trees are going to start dying out that don't have their heads up in the canopy and getting full sunlight. And so our little oak seedling here is still hanging in, but as you can see, it's really being outcompeted by the poplars that are around it. And so one of the things we're hoping is that on the edges of the gaps, the seedlings would be more competitive. Maybe not grow as much, but be a little more competitive and be able to respond to the increasing gaps, re-entry when we come in and increase the sizes of the gaps over time. And that is hopefully what we're going to see happen. And we tried to actually do a little small release of these oak seedlings in here this last growing season. Whether or not that's going to be successful, we have yet to see. I think it's virtually really difficult to release oak seedlings unless they're about 60 to 80% of the height of the competing vegetation around them, which this one clearly is not. So another component of this study that we wanted to look at was not just the natural regeneration of oak, which is what you've probably heard a lot about, but also artificial regeneration or planting. So one of the things you really want to consider when you're considering planting a species out in the woods is, do you need to plant a species out in the woods? Can you get those species naturally without planting? Because planting is a cost. It's going to cost you money to get the seedlings. It's going to cost you money to get planters. You've got to make sure you've got the right stock, to plant out here. So one of the advantages of planting a species, no matter what species it is that you're automatically introducing and increasing the stocking of that species in the woods. So that's one thing to consider as an advantage. Another possible advantage is that you can improve the genetics. And this is particularly true for species like loblolly pine in the south, where there's definitely genetic improvement of those species. Also some western species, there's been a little bit of work on genetic improvement of those species. It's a lot harder with hardwoods. They're more complex, they're more genetically diverse, but there is definitely improved stock of hardwood species. It's just harder to find than with conifer species. So those are the things that you want to consider when you're planting. Another advantage of planting is with climate change, you can plant species and do what we call assisted migration. So you can plant species a little further north than their current range, in hopes that they will adapt better to that environment over time as our climate is warming. And they're doing this in Minnesota, for example, with hickory species. This particular study, we are planting white oak, Quercus alba, and these seedlings did come from a seed orchard that is a local seed orchard managed by the University of Tennessee's Tree Improvement Program. And we do consider them improved because that orchard has been thinned over time to select the ones that are fastest growing and the best acorn producers. So we do consider these improved, probably for acorn production. So these seedlings that you see here hopefully do have genetics for early acorn production, which is a really important thing that managers want for wildlife species. White oak is highly valued by many wildlife species, black bear, etc., even over red oak species, because they have less tannin in the acorns. So we planted these seedlings. They were bare root seedlings, and that's another thing you really want to consider when you're looking at artificial regeneration, is what kind of stock you're going to use. So you can use containerized seedlings, you can use bare root seedlings. With bare root seedlings, there's a numbering system that's used to describe them, and these are what we call 2-0 seedlings. So they were grown for 2 years in a nursery bed and then lifted. That second number refers to if those seedlings were transplanted into another bed, which we don't generally do with southeastern hardwood species, but a lot of western conifer species sometimes do have that happen. Also, there's containerized stock that you can look at. That is going to be more expensive probably, especially with hardwood species. So you really have to consider the site that you're planting on, the species that you're dealing with, and all of those things when you're just trying to figure out what stock of species to plant, and how many that you're going to plant. We planted these on a 12 by 12 foot spacing, and that's a pretty wide spacing, but we're trying to mainly enrich the site with white oak, not completely turn this into a white oak plantation. So this is really more of an enrichment planting that we're looking at here. And within this particular study, in the gaps, we planted inside the gaps, on the edges of the gaps, which is where we're standing now, and then out into the forest matrix to see how these white oak seedlings would do in those different types of environments, and also in relation to the direction of the transect itself, north, south, east, or west. And what we found is that the seedlings actually did the best, of course, inside the gaps. So where they had the most light, the most resources in terms of water and the soil, that's where they did absolutely the best. But so did everything else. So the poplars and the cherries and everything else came up along with the white oaks and is overtopping the white oaks. On the edges is where we were hoping to see the white oaks have the best competitive ability. And this one right here actually does have a pretty good competitive ability. You can see there's nothing above it. It's pretty much free to grow. You know, it's a competitive tree species. And out in the forest matrix is where we expected to see the seedlings do probably the worst, and all of that is actually true. So out in the forest matrix is where we're seeing our seedlings, you know, not growing very well. They're getting more browsed by deer compared to the seedlings inside the gaps and on the edges of the gaps is where we're seeing the trees having the best growth. One of the other things you really want to consider with artificial regeneration, especially with bare root hardwood seedlings, is the size of the seedlings. You want to really plant the biggest seedling you can find, but you want to balance that with the cost and the logistics. So it's hard to transport large seedlings, it's hard to plant large seedlings, and all of those things. So you want to make sure that you're balancing the cost of planting larger seedlings with the benefit of that seedling being more competitive into the future. And if you're in an area with deer, you want to get that seedling above deer browse quickly. And the one way you can do that is plant larger size seedlings. If you're in an area with a lot of deer, you're going to have to consider fencing, you're going to have to consider repellents or shelters. That's you know, a really important part of artificial regeneration in many areas. So one of the important things about planting species artificial regeneration is where your seed comes from. You want to make sure you get local seed sources. The Forest Service does have some seed orchards set up for specific species throughout all the different regions of the Forest Service, and they actually in some regions have their own nurseries. And so you need to get with your regional silviculturist and regional geneticist in determining what is available to you in that regard. If you're going to plant a species where you can collect that seed locally from your seed orchards, or are you going to have to go to the open market and go to the nursery, a commercial tree nursery, and ask them for seed and seedlings from that nursery? And you want to be very careful about that. A lot of commercial nurseries do not use local seed sources. In fact, they oftentimes don't really even know where their seed comes from. So you want to make sure, ideally, that you collect the seed yourself or get it from a known seed orchard and get it to a commercial nursery or a Forest Service nursery to grow your quality seedlings, and however that looks, if you're doing containerized seedlings or if you're doing bare root seedlings or transplant bed seedlings. It's really important that you get that seed adapted to the site that you're planting in. And that is also important, not just in terms of regionally, but in terms within your region. You don't want to plant high elevation sources on a low elevation site or a low elevation source on a high elevation site. Now, with climate change, you can do a little bit of assisted migration in terms of planting things a little bit further north and maybe a little bit more upslope. But again, definitely consult with your regional geneticist on that to determine what's really appropriate. There's a lot of models and a lot of tools out there available to you to help you make those decisions. One of the other components of this study is a herbicide treatment. And the reason we wanted to implement that was to be able to see if an entry of herbicide, application of herbicide, would help oak be able to recruit better into the canopy. And so we actually applied an herbicide treatment prior to harvesting out here to get rid of anything less than 6 inches in diameter. And within the gap centers, basically what that did was it prevented anything undesirable less than 6 inches from sprouting that would compete with our oak species that we were favoring. Out here in the forest matrix, what that looks like is what we call a mid-story removal, where basically it's going to decrease the number of mid-story species so that the oaks that are in the understory will be able to grow up a little bit more and get larger in size. And so we treated species like dogwood and maples. We hacked this tree here. We hacked this one over here. And so you can see these are no longer producing shade to the understory seedlings of oak. Now, one of the things that does happen is there's also small red maple seedlings that are also in the understory. And yes, they also benefit from this treatment as well. So that was one of the things that we didn't really want to see, but it's one of the things that has ended up happening. It's predominantly red maple. So you can see there's little red maple seedlings here that have come up since we did the herbicide treatment. But given that, it still is helping the oak seedlings out here get into a more competitive position and keeping them in the system longer. Which is really important because we want to be able to eventually get those seedlings up into the canopy, especially when we do our re-entry of our gaps, and make those seedlings more competitive and larger in size so that they can be more competitive against these red maples.